Let's fantastic. Welcome everyone, and thank you for attending the training course. This is the last module, and we will have Ken Bia here. Ken is a really good friend of mine. He's a lovely person, a very sociable. Like we catch up, at conferences, dinners, this way, that way. He's a lovely person. I enjoy working with him. But Ken is more than that. Ken is one of the people that I believe has changed the concept of road safety training in Australia and New Zealand. A wonderful influencer. So I wanted to sort of do something unusual with Ken, like asking questions instead of introducing Ken. So Ken, tell us a bit about your more than 25 years of history and why did you choose road safety?
Oh, okay. I'll briefly answer that. I was a civil engineer went into the road authority in Victoria, Vic Roads, fairly early in my career. I did a bit of stuff in high voltage power distribution, which was not my thing. But into civil engineering in the road authority, did development of lots of different road projects and design and standard stuff, and but worked on some of the black spot programs of the time in terms of that development, design, engineering side of things. But that really sort of captured me in the fact that we can engineer, we can design risk out of the road network and actually save people's lives, prevent serious injuries by good road design. And that wasn't something, it's obvious to a lot of us now, but that wasn't something that I'd put together in my mind that, we can make real difference in people's lives. We don't know whose lives, but that's okay. By just doing things better with better knowledge. And then went into the road safety department and really got engrossed in that, and then had the opportunity to just work on wonderful programs, the absolutely fantastic sort of major funding programs, the one that you were in control of, the billions of dollars for the Safe System Road Infrastructure Program, and being involved in the rollout of that, and it just amazing. So absolutely just grabbed all of my passion and been running with it ever since.
And also, I really like to emphasize that what we're doing, we don't know who we're going to influence, whose life we're going to save. And that's the beauty of it. It's so democratic. And I mean, so in line with our values. So, Ken, you've done like multitude of safe system assessment, road safety audits, trainings, teaching about road design. Like, what is the key learning that you can share upfront with the crew here before we jump to the actual training? What have you learned?
I think always understand the principles and teach people and teach others the principles. New people coming into our industry, if we can get them to understand the fundamentals and the principles, specifics of how we achieve that will change, and it'll change with politics, it'll change with technology, it'll change, with different bits and pieces. But if you have a solid foundation on what we're trying to achieve and the core principles of things, people are fantastic. And really, like, I work with engineers, designers, technicians, and the like. They are problem solvers. That, like, to the core, they are problem solvers. That is what they want to do in life. And we just need to frame the problem correctly to them and give them that. And they will do amazing things, and they always do. And that's where our best stuff comes about. So I'm passionate about principles, frame the problem, and just let people innovate and come up with amazing things.
I love it. And this is like really interesting. I had a conversation with Professor Rod Troutbeck. Very similar answer. So with that, Ken, the floor is yours.
Thank you, Hafez. And I am going to jump into things. People, hold on to your mouse pads because I move pretty quickly through this. But I do that to cover a lot of it. You can always follow up with me in terms of any of the specifics if we didn't get time to delve into the detail of it. My contact details are in there. You can, that's a QR code to my LinkedIn. Just search up myself, message me, ask me questions. Happy to continue the conversation because we won't be able to get into everything in a lot of detail. But what I am going to cover off today is some discussion around ramp grades. And I will go into that into detail because I think it's an important, really important, critical thing about getting appropriate speeds is understanding ramp grades, what can and can't be done where they're appropriate. We'll jump into signs and lines a bit. I have roundabouts and positioning as an important one. Roundabouts have wonderful characteristics, and they, there's a lot of benefit, but pedestrians and cyclists aren't getting those benefits, but we can do additions and we can certainly get that. Sight lines, huge one here. It's probably one of the least understood things about raised crossings, in my opinion, is properly understanding how to make decisions around sight lines. And I'll briefly touch on lighting and drainage, and I'll at least point you at where the technical information is. But as Fez has popped into the chat, put your questions in. Don't wait for me to stop to ask, are there any questions? Because I will move on from that pretty quickly. Okay, design objectives. We have had wonderful presentations from Hafez, from Bridget, from Prue, that have covered off a lot of the design objectives. So I don't need to delve into that, but it just reminds you that we really need to be thinking about those desire lines for pedestrians. And I say cyclists as well. Cyclists will move a bit further off desire lines, but pedestrians are really adamant. That's where I want to go. I want to take the shortest and easiest route there. And we need to design for that. Okay. Trying to corral pedestrians like sheep through areas not only is ineffective a lot of the time, it degrades the place value of an area. And also can increase risk. People get trapped on the road because they're walking, there's a pedestrian fence or something like that. So really good crossings on desire lines if you are providing specific crossings as opposed to creating whole shared zones or areas without vehicles. We want to think about all users, and Bridget really delved into that in a lot of detail. We want to have high alignment with safe system principles, and Hafez set a wonderful, foundation for that. I'll probably go into a little bit more specifics about some of that, but I think you've got a good foundation for that. And we want to consider this at a network level. So discontinuity through a travel path, one raised crossing and then coming to the next point where you have to cross and then having nothing there, it doesn't present that safe and connected route that we need to think about. If we go into some specific on design principles, this is where we get some interesting stuff. And I talked about instilling great principles so people can then take these forward. You'll see here, this is one thing. I talk about the severity of a crash first. That has flipped design thinking on its head that's been happening for a very long time, where it's all about the likelihood of crash, stopping crashes happening in the first place. And only when there's lots of crashes and some real big problem, they start to maybe think about severity. No, we need to put a foundation, a major design parameter being the severity of crash and keeping it within tolerable levels. We're still going to do everything we can to reduce the likelihood of crashes through great sight lines, signs, lines, good drainage, lighting, and also speed again. But really thinking about that severity is so important. So I'm going to start with sight distance. Okay, and I mentioned this one I think is poorly understood, associated with raised crossings. This is one where traffic engineers and road designers really great usually at doing this for vehicles at intersections. But how to think about it for pedestrians and cyclists crossing either with priority or without priority is not as well understood. But I thought a bit of interaction to get us going, Hafez, and I've got the thumbs up, thumbs down wombat there. And what I want people to do is use the emojis, the thumbs up emoji or the scared face emoji. For this crossing, you can see here in Queensland, you can see this is a divided road. It's got two carriageways. and approaching the pedestrian crossing, so zebra crossing. Okay, I'm seeing scary faces, Hafez. And that's good. I mean, it's a kind of obvious one, but we do see a little bit of this. There's a few things to it. Lots of scared people there. Okay, thank you. For those who are scratching their head a little bit and maybe just putting a scared face up because they saw lots of other people do it, let's unpack why we're not so happy with this. Okay, well, there's some good things about it. It's got a bit of a curb out stand. It seems to be well lit. We've got some signs there. But we've got these 2 lanes approaching. And I thought I'd use this diagram to sort of explain a little bit about why 2 lanes or 3 lanes even, approaching a priority pedestrian or cyclist crossing is not ideal. And I do this with a little diagram here to show you what we call a dynamic visual obstruction, or it's a moving sightline impediment. It blocks that vision to something. And in this case, it's blocking the vision to crossing pedestrians. Now, we have this nasty scenario, and we see this in different crash reports, or we've done some fatal investigations under some not that dissimilar circumstances, where this driver is moving in at speed, this one's following just behind, this one slams their brakes on because a pedestrian's moving through quite quickly. This one doesn't have that, and we have that collision happen there. So that's something we're always aware of. The Australian standard says, no pedestrian crossings on 2-lane roads. There's some work being done investigating, is that the case? What context are we talking about for that, and other bits and pieces. But let's have a look at a pedestrian crossing on a 2-lane road here, which is, got a different configuration. But let's do some thumbs up, thumbs down on this. And Hafez, I see some things coming in there. Was there anything I needed to deal with at this stage?
Well, I think no, people talked about some of the pros and cons of the previous solution, and I think as you mentioned, we need to acknowledge the good work done, but we need to think about improvement as well.
Yeah. Okay, I've seen more thumbs up here. This is good, and that's right. Like, what I want to say is that we can tweak things to still get some reasonably good outcomes here, even in these scenarios. Okay, it's a little bit more land here, but what we've created is a slower environment, so the raised component being a really important aspect here. But we've also done this separation and opened up sight lines to crossing pedestrians from vehicles in either lane. And so if you go a little bit closer to this crossing, you can see a truck if that truck had been slamming on their brakes, there's still quite a sight line opened up there. If the truck was in, at a closer proximity, you can see the sight lines are further blocked. So essentially, like in that diagram we had before, we're putting a separator, some sort of separation there, meaning that we open up sight lines to that pedestrian, give that space, and give this driver the opportunity to see, react, and stop. The raising of this and the slowing of these vehicle speeds is going to be another thing that significantly helps as well. Okay, let's talk about some parameters around sight distance at pedestrian crossings, raised crossings, or at grade crossings for that matter. Okay, so the 1.2 meters a second is what we take as walking speed. However, I don't want you to just blindly take 1.2 meters a second on walking speed, because if it's a running track, or like a track that comes straight into the crossing, it's going to be faster than that. This is kind of thinking about pedestrians walking along a sidewalk, a footpath, and turning onto a crossing and the like. 1.6 meter setback is the sort of point we usually say we want to start that real vision to that pedestrian crossing. Now, that's for pedestrians. We'll talk about cyclists in a bit. In terms of what eye height, we think about eye height for crossing points a lot. We use a 1.07. It's very, very specific. I think they could have just gone 1, but that's okay. 1.07. And that's thinking about someone in a wheelchair and that eye height, a child as well. So there's some key design parameters. We're going to talk about approach sight distance, crossing sight distance, stopping sight distance. Some of you know these quite intimately, others maybe not so much. So I'm going to talk about the basics of them, explain what they are, and then we'll get into a bit of the calculation. So the 1.6, sorry, so Mo's question just came in there. It is from the start of the crossing. So if you had a curve outstand, it would be from the, you'd be in the curve outstand for that. Okay, so a common mistake that people make is to simply go to the road rules around parking restriction requirements and basically say, well, if I meet that, I assume sight distances will be enough. Now, this sort of doesn't work at both ends of the scale sometimes. And what I'm talking about there, here I've put in the actual specifics out of the road rules. So the Australian road rules, or the standard template road rules, each jurisdiction then takes it, but they're all the same for this one. They talk about 20 meters before the crossing and 10 meters after. Now that has been put into road rules associated with sight lines, right? But it has no context to it whatsoever. All right. New Zealand, for example, in the road code, they have a 6 meter one on the approach. So people are making calls on this. But the reason I say this is in some situations, 20 meters is excessive, right? And if you rigidly stick to, we must get 20 meters here, right? You actually find that some councils and some jurisdictions don't put in pedestrian crossings because they can't remove a car park or one reason or another. So that's not a good thing at all, right? The other scenario sometimes is the 20 meters is not enough and we're actually causing, an issue. So you actually need to say, okay, that's part of road rule requirements, but we need to understand the principles of this and make our call based on that. Now, approach sight distance, ASD, is the ability for a driver to see the pavement, the point we need them to. So we use approach sight distance for vehicles on the approach to intersections that they have to give way or the like, but you use this and you want that driver to be able to see that there is a crossing there. We want them to be able to see the pavement of that crossing. And it's important, the pavement, because if we're thinking about horizontal grades, coming over something or the like, we need to be conscious of this. And you can see there that we've got reaction time as one of the elements to this. That is, how long does it take that driver to realize they got to do something and then lift their foot off the accelerator and put it on the brake? That's reaction time. Okay. So we use different times based on the driving environment. So on country roads, you're driving, I don't know, the Pacific Highway, we have a longer reaction time because people are a bit, they're just sort of cruising and they're driving. In city spaces, and there's lots going on, their reaction time is down because they're really, they're quite part of the driving task at that stage. Okay, we've got operating speed, and we use 85th percentile speed here. I have major issues with 85th percentile speed in some situations. I'm okay with it here, all right? A coefficient of deceleration, that's essentially talks about the surface friction that we've got. So when they hit the brakes, how are they going to be able to actually get traction? And then the longitudinal grade. So that's, if it's on a downhill or an uphill or the like.
Ken, a question here, is warning sign, do warning signs have an impact on this calculation?
Yeah, okay. So reaction time, you just take a factor based sort of on the general land use environment. You don't tend to change your reaction time based on the specifics of the design, but as you get into that, you might make a judgment call as a designer to lessen your reaction time if there's really great, warning devices, maybe there's some rumble strips on the approach or these sort of things, which we go, okay, we've alerted this driver. Then you're able to start to lower your reaction time possibly. But for most pedestrian crossings, we are at the lowest reaction time available in Austroads because they're in these urban environments anyway.
Thank you.
Okay, so what we want to do is ensure we're meeting that ASD, that approach sight distance. People can see the crossing, they've got enough time to react, to make themselves aware there's a crossing. Now, Austroads has, in recent times, done something I'm not happy with, and I've told them about that, and they have promised me they are changing it in the next round of the Guide to Road Design, which they're working on. We've had Queensland's either come out with or about to come out with the same conclusion that I made, which is this is ridiculous. But I'm going to tell you what it is, and then I'm going to tell you the other way we need to think about it. Crossing sight distance, CSD. Crossing sight distance is essentially saying this pedestrian needs to be able to look up there, see a vehicle, right? Have enough time to make it across the crossing before the vehicle arrives. Now, the reason we have in the past not used crossing sight distance for pedestrian priority crossings is because who cares how long it takes a pedestrian to get across there? They have priority. It doesn't matter if that's 5 meters or 50 meters, right? It should not matter, okay? Now, Austroads' justification on this was, well, it is a safer, it's a safer situation if we've got crossing sight distance rather than stopping sight distance, which is the next one we'll talk about, because crossing sight distance is going to be longer, right? This means that we'll have this bigger sight line open, big sight triangle open. It'll be massive and clear and really be able to see pedestrians approaching the crossing. Now, that sounds great. And don't get me wrong, I'm absolutely saying, yep, that will be a safer scenario for this crossing. However, what it will result in is so few crossings going in across the network, because meeting these CSD requirements, it's big. And most of these we're talking about raised crossings here. I am talking about raised crossings in urban environments. There's car parking, there's constraints, there's buildings. Meeting this is so hard, and people may just simply go, well, we can't do it because we can't meet that. And we definitely do not want that. So overall, it will be a far less safer scenario if we take CSD. Okay, but I'll sort of briefly explain how you do that. That's the sight line we're talking about. It takes into account that 1.6 meter setback, 3 meter, 3.5 and a 3.5. And you need to have a think about the operating speed of vehicle, 85th percentile speed on the approach. So in that, we take then the distance to cross. So that's the distance to cross. We take a 1.2 as the speed that the pedestrian walks. Remember, we talked about the speed. We add 3 seconds here for the pedestrian to, drop stuff or have a look around or start to get going. Again, doesn't make too much sense to me on a pedestrian priority crossing. And then we put the 85th percentile speed and a 3.6 there, which is a factor that is just in the formula. Okay, so you calculate that all out, and you get this sort of 141 meter sight distance. So that it's huge. Now that's admittedly at a 50-kilometer per hour 85th percentile, but you know that's what that is. Okay, but if we raise the crossing, right? If we raise the crossing, then what happens? Well, vehicles get in a very different mindset. There is a physical object to now go over. Thus, we get lots of different advantages. And actually what will happen is the driver will approach the crossing. It doesn't matter if they've seen or not seen a pedestrian. Their foot leaves the accelerator and goes onto the brake because they have to navigate over this raised thing. And they slow on the approach to it. That's important. So there is occasionally this misconception that people, you know, it slows them down somehow. No. They see it, they slow down because they've got to navigate over this thing. But what we get there then is this interesting thing where they're traveling along at free flow 85th percentile speed, say that's 50. We've designed the crossing with ramp grades to get a 25-kilometer per hour speed over it, for example. And I'll talk to you about how you make those choices and get to those numbers in a bit. But, you know, do we then say, okay, well, let's take this 25 as our 85th percentile speed, or do we still use the 50 as the 85th percentile speed? This one is going to be much shorter, isn't it? Because we've taken a lower speed. And you can calculate that one out and you get that 71 meters in this scenario. I still think that's excessive, by the way, but that's a much lower, it's half of what we were talking about before. So you can see there is an immediate advantage in raising a crossing. Like before we get into all the safety benefits of raising a crossing, you actually narrow down your sightline possibilities, that your absolute sort of minimums are going to be far less, which means that if you're constrained with car parking or other things, raising the crossing just becomes a very logical thing to do to improve your sightlines. Stopping sight distance, which is what I talked about before, is actually now for the driver to see the pedestrian at 1.6 meters back and have time to react to that, lift their foot up, brake, because they go, oh, I'm going to have to give way here. That is how sight distance at a crossing should be done, and Austroads will sort of move back to something like this in their next iteration, they promise me. Because if we run that calculation, we see that same 85th percentile speed, it's down at 48. And now that is more like if you actually get out there and you measure them and then you drive them and you walk them and you really feel this is more appropriate for crossing points. I'm slightly uncomfortable with non-raised crossings and this, right? So yeah, in one sense, the raising of the crossing just makes all of this far better. But that's stopping sight distance at that number. Now let's go back to, so we're still on stopping sight distance here, but I just want to explain to you sort of the principles of how this works. Okay, we've got, that's stopping sight distance would be 17 when we've raised the crossing. Now that's really quite low. And what actually sort of happens in this scenario is that a driver's driving along, they're going at say 50, that's their, just cruising speed, right? They're going to hit this ASD point, which is where they can see the crossing. Then they react. They lift their foot up, right? And they start their braking scenario. Then they slow, and this does not matter if they are able to see the pedestrian or not. They're going to go through this slowing, right? Then there's this critical point. The critical point is where they make that decision. Do I continue to brake to a stop, or do I take my foot off the brake and put it back on the accelerator, or to go over the crossing, right? And so that's your like critical, your critical point there. So the reality is this is top end design requirements. If you can meet, you need to meet ASD to make sure that they know that there's a crossing coming up, right? But do you take the lowest, which is the ramp grade speed, or do you take the free flow 85th percentile speed as the point you need to draw your sight triangle from? It's somewhere in between those. Think of those as the bookends of your sight distance triangles. In constrained scenarios, you might be coming down all the way to this, and if you've got more space, you'll be opening up to this. And there'll be a significant difference in these. Now, where I'm not comfortable going to, and in one sense, you could theorize that this should be the case, is maneuvering sight distance. So, gap sight distance, I should say, gap sight distance, which is essentially what you would be doing if you assume every vehicle comes to a stop, basically, at a pedestrian crossing. Now, they don't do that. That's just the reality of it, is they don't do that. So we will jump past that one. Now, question for the group, and I see some stuff is already coming in there, which is great, Hafez, but I've got a question for the group is, okay, if we've got this road and unfortunately we can't quite meet our sight distance requirements, either CSD or SSD, depending on where Austroads has finally got to. But either way, what are some of the things we might be able to do if we can't quite meet that? What design changes could we make to get us closer to our calculated sight distance requirements? Any ideas there? And maybe while people pop them in, Hafez, you can tell me.
For sure. And then there will be a prize here. The best answer will get a prize here.
Oh, I like it. I might give out a few depending on how we go.
Yes. So we have vertical deflection, devices like speed humps, cushions. We have rumble strips. We have technology like flashing lights, playing with horizontal deflection or lane widths.
Okay. Wow.
Signalization.
I'm liking what I'm seeing here. Lots of good ideas. There's one that is, I suppose, a more common thing done that nobody's quite popped in there at this stage. But we will give out some prizes here, Fez, because I do like some of this stuff. So I like the idea that people are talking about the speed. I mean, we saw the formula. Speed is going to be a critical factor in sight distance, isn't it? Mm-hmm. So if we can reduce the travel speed of the vehicle approaching, the sight distance requirements comes down. And people have done that. I like the way some of the people are doing that with talking about, possibly some sort of speed calming at this point, physical speed calming, a raised, like a speed hump or the like. Okay, wonderful, wonderful way to start to do that. You can bring that speed right down early. We had quite a number of people pointing out things to alert that driver more. Now, there's limitations on that. Like, it's good. It's not going to be as effective as something physical like this. What you're in that sense trying to do is ensure that reaction time is as low as it possibly can be, right? And that they're very aware there's a crossing. So that's good. If we have ASD, approach sight distance, and a clearly, correctly marked crossing, adding more warning signs and things on the approach probably isn't going to do us a lot, but I do like people making sure that is the case. There we go. Ken has come up with curb extensions. Ken can get a prize for that. I mean, everybody's actually coming up with really good things there. And but I think curb extensions is a really important one for us to think about because it just opens sight lines up really well. So curb outstands, curb extensions give us that nice, better sight line there. And you'll have a significant difference. Now, these diagrams are a little bit, they're just a bit artistic. There were some other good points in there, and Richo can probably have a prize in there because at some point here in different restrictions and contexts, you're actually going to question your crossing form, and you may look to a signalized, ideally raised crossing at different points. So if we think about that, a scenario we have seen a little bit of is maybe the desire for a raised crossing at a roundabout like this diagram, and not meeting that 1.6 meter setback on that approach. Now, you want to think about the 85th percentile speed of a vehicle going through the roundabout. Don't take your free flow 85th percentile speed somewhere back here, because that's not relevant when they're in the roundabout slowed down. But one little addition here, okay, they can meet ASD, so that's good. They know there's a crossing, so they're going to be going slower. But if we're able to add raised crossings at these different points, we're ensuring that lowered speed at that critical point. We open up these sight lines.
Ken?
Yep.
Emily has raised this question a couple of times now. I sort of, identify with that. Some of the curb outstand, curb extension, some of the facilities for pedestrians interfere with cycling movement and cycle lanes.
Yeah.
What are your thoughts on that?
Yeah, that is a legitimate challenge. So an on-road bike often gets squeezed or can get squeezed in with vehicles going through as with the curb outstand. And so you're in these awkward situations. I mean, there are designs with cyclist sort of bypass facilities. You need to design them carefully to ensure that cyclists and pedestrians aren't having major, conflict issues, but you can sort of pop cyclists essentially behind, a little bit sort of floating bus stop style, but in a slightly different scenario. So there are options there. If you've got the road width, though, you can still provide facilities. I've got some pictures coming up later of where the cycle facility still remains and it's got curb outstands.
Ken, in lower speed environment, what about sharrows? Are they as effective or safe? Any thoughts?
Well, you preface that with the important part there, Hafez, lower speed environments. It really does have to be pretty low speed environments where we, have that sharrow, the encouraging of a cyclist to claim a lane. I'm always quite cautious with that. I have that preference of separating out. I'm thinking about also like trying to get young people on bikes and those sort of things. I'm certainly not going to let my 8-year-old, go out there and try and claim the lane over a four-wheel drive or something like that. The sharrow, it's just we won't ride that road. And so that's, but if we provide those separated facilities, we get a much broader cross section. But in some scenarios, that shows clearly that a cyclist, will be there and they get priority. And I saw Peter's question there. What's a sharrow? Here's my bike. So it's a line marking on the road that kind of looks like that. Actually, it's a lot better than that, though. But it's just pavement markings to indicate what that a bike will be sort of taking the lane at that point. All right, let's have a look at this one. Again, not a raised crossing, and we've got some tactiles there, and we had a little bit of discussion, Prue and Bridge and Affairs, talking about making sure we provide those crossing points at where people are going to cross, bus stops and the like. Okay, we've got a few scared faces popped up there, and anytime you see the little wombat thumbs up, thumbs down is to where you either put the scared face or the thumbs up. Yeah. Okay. Now, this again is one where some of the traffic engineering, road design, and road operation manuals do what I say is not common sense, which is where they say that a parking spot or a bus stop is not a sight distance impediment because it's not a permanent feature. And I'm like, no. I mean, here's a picture. Clearly, it is a sight distance impediment. And we need to factor that in our design. So we definitely want to have our crossing points close to the bus stops. Absolutely, because another bus stop there, and either going to work or coming home from work or going to school or coming home from school or whatever, you're going to get dropped on a different side of the road, or you're going to need to cross to get on your bus. So we want to provide that crossing point. But yeah, think about that bus will create a significant sightline impediment at the crossing. So either the other side of the crossing, or as somebody said, indented or the like, would be a good option here. Okay, let's have a look at this one. Now, I was out there with a colleague undertaking the pre-opening or road safety audit on this. So you'll see that the flashing lights are not in use at the moment, so don't worry about that. Lots of thumbs up. This is good. Yeah. Yeah, and I tend to agree. I mean, I think this is a really nice, it was a pleasure to do a post-opening audit on this. It had, beautiful raised features, nice ramp grades, a really clear crossing, great sight lines to the crossing. The signs are nice. It's all looking really good. The lighting was really good. And I think, a really wonderful example there. Now, one of the things we did notice, and as many of you are probably road safety auditors as well, and you try and get out there at day and night, and when there's lots of different activity, and there's a school here, and it's got some netball courts and those sort of things. We went out there when we knew it would be a very busy time, and unfortunately, people were using that little area as a car parking spot, which is a clear, like, it's marked no standing, no stopping. You can see from here, but that driver's well up into that. So I just flagged that again as something to be aware of as you're designing these, that people may, in some situations, use that just to prop to wait and the like. So we need to possibly cater for that in our design. And you can do small features here to discourage that. You can sort of build out your curb out stand further back a bit. And that can prevent that. You can, or you can do some minor spike down curbing and these sorts of things to discourage it. Oh, Wombat's having a field day here with the thumbs up, thumbs down. Now, you don't get a lot of context in this one, but yeah, thumbs up, thumbs down. Okay, we've got a few concern, okay, this is good, yeah. And I suppose it's probably indicative that you don't have much context on this one, that we're seeing a bit of a mix here. Generally, actually, this one I thought was really pretty good. I still think we're going to have issues with a bit of sight line. They've got the curb out stands, it's better, but something in here would be good, right? But generally, nice raised crossing, nice sort of tactiles. One thing that's interesting to think about in these is the height of any foliage, any landscaping, any signage in these curb out stand areas. These are like a gold mine to landscape architects and designers. They just see it and they're like, oh, right, this is where we're going to put our big entry signs into the township, our sculptures. We're going to put big flowering bushes and these sorts of things. That's what they want to do, because you can imagine it's a beautiful area. It's a new area that they get to play with and the like. But what we want to really ensure is that we have this 0.5 to 1.5, ensuring that we have that as a clear window to be able for drivers to see, but also pedestrians to see out. Now, if you followed, again, absolute specifics of the guideline, you'd go to 1.07 up here. Because you remember I showed the wheelchair person and their eye height was at 1.07, right? Now, that doesn't make sense. So, like, again, this is thinking about a pedestrian at a non-priority crossing, not a priority pedestrian crossing, being able to look and see and pick a gap where they can scurry across the road, right? But if you're thinking about a driver approaching, all they're going to see is the little top of the head of somebody. And that, to me, is insufficient. So down to 0.5 to 1.5 to ensure we've got that, ideally, low ground cover. And I think this one's probably a nice example from lovely Warrnambool, where they've done some amazing, awesome stuff in the CBD there with raised crossings around the roundabout and making it really pedestrian friendly and low speed and the like. And nicely done. I mean, the beautiful sort of ground cover, nice there, but low. The other thing I point out on this one, and be interested, we've probably got some accessibility experts in the group and they can talk a bit more about this. I really like the fact that they've provided this hatched area here, because if you put an angle park right up to a pedestrian crossing, people back out over the crossing, and that's not great, not ideal. But this means that, you know, this will back out into that position. They've also got the disabled park there. Now, somebody did mention, you know, that's the incorrect side for that. So I'm not 100% sure on that. Accessibility experts will be able to fill me in on whether that is sort of compliant or not and is going to provide that facility. But the idea of not having somebody back over a crossing to get out of their car park is an important one. Now, what are we, sort of 15 minutes from a break, Hafez? Is that right? Okay, right. I've been talking about pedestrians, 1.2 meters a second walking speed generally we're taking with priority crossing. But what about if a bike has priority crossing? Okay, what speed would we use that bike rider is going to be coming in? Because remember, a driver has to be able to see this bike rider and you know, make a call associated with that. And that's going to be determined on the bike rider speed and the vehicle speed, of course. So for bikes, we take a 1.4 meter high when we're thinking around it. We've got some guesses in on the speed. Which I'm going to show you some of the speeds, but hey, let's give out some prizes. If there's anybody who guessed a speed gets a prize for just getting involved. There's different speeds from different sources. There's some nice research there that I've referenced, which shows some different ones on uphills and downhills and males and females. TMR in Queensland, they talk about a 15 to 25. A 4.1 to a 6.9, which is in the range people were talking about there and guessing, which is good. So that's giving you a general idea of some of the parameters. I mean, I like to sort of talk about a 15 in these environments where they're sort of making some turns and decisions around the approach to the crossing point. 20 of it's fairly straight through, 20 to 25. Actually, I go to 30 kilometers an hour for a dedicated cycleway with priority because you really know they're motoring along there. And if you're not doing anything to sort of adjust cyclist speed at that point, 30 is kind of where I
can. So we have a winner here. Delep guessed 20, correct? And also honorable mention of Delvis and Peter.
Okay, give them all prizes.
Yes, Delep guessed the prize.
Okay. All right, so we are essentially in these scenarios creating an intersection. I want you to think about this as an intersection, like a road to road intersection. All right, because we are saying, this is sort of how we sign it. We say it's a road going through here. It's just a road that actually only carries bikes and pedestrians. But let's think about it and sign it and mark it accordingly. We add this little supplementary plate, and that's now either just been released or is being released as part of the Australian standard on that. But that's generally how we mark it. If you've got these locations, sorry, I should say, this is where we have a shared path crossing a road. Now, that kind of originated because of these weird little road rules around you can't have a bicycle ride over a pedestrian crossing, a zebra crossing, right? Technically, they would have to get off their bike, walk across the road. So some jurisdictions allow riding on the footpath and riding over pedestrian crossings. So for people saying they may not have seen that before, the case could be that you're allowed to, ride in these circumstances. But a lot of jurisdictions are going down this yellow crossing, mark it like a road perspective. There is the other alternate option, which is to provide your cycling facility next to your pedestrian crossing, right? And in this scenario, you can see a couple of them here. We would mark that as the pedestrian crossing. You'd actually technically need to mark it with a giveaway as well in order to prioritize that cycle way through there. You're getting excessive signage in these circumstances. People recognize that. But in these scenarios, I want you to ensure that you're getting sight triangles, sight distance to the cyclists. They're going to be the ones that are going to be the most critical because they're moving faster. So let's have a look at one of these yellow crossings, and you can see that in this scenario, the rider, which is actually me, and if you look out here, you're seeing this car, and they come into view there, and they should have enough time to see me and to stop and brake. But under these scenarios, we actually want to provide enough distance, sightline, for me as the rider to slam on the brakes if that car looks like they have no intention of stopping. Okay, now there's lots of different guidance out there. I think in this case, the Victorian government has done a really wonderful job in the design principles for raised priority crossings, especially around how they've dealt with sightlines. It's a good document, and I've put a copy into the learning management system for you, but you can certainly just Google this and find it. But I'm going to take you through the process for looking at sightlines for these priority crossings under these guidance. And some jurisdictions have no guidance whatsoever on this, so it would be appropriate to use this. And I'll show you TMR's got a little bit of unclear guidance around exactly what they're thinking on this as well, which would be less than this. Okay, I'll do this, and then I'm going to let you have a quick grab of a coffee or something like that. So, safe intersection sight distance, safe intersection sight distance, we hadn't talked about that one specifically. That is SSD. That is stopping sight distance with some slightly different heights you're looking at. So the formulas are the same. But because we're saying, okay, this is kind of an intersection, we're going to think about it in that context. And what you do is you need to pick your travel times, and you base these on different scenarios. Are we in high-speed environments? Are we in very low-speed environments, constrained environments? So what we're talking about here is we have no sight distance there, and we see the car doesn't have enough time to stop, and even though they slowed down, there's been a collision. If we open up sight lines there, at some point, we will have the ability then for the car to come in and the bike goes through, the car saw them in time, slow down, let them go through. But we also want to try to provide this scenario, which is where, oh, the car didn't quite, I'm going through, but the bike slams on their brakes because they've gone, oh, they're going too fast. So we're providing that genuine, like, multi-sight triangle in these scenarios. But the configurations come in 3 different scenarios, really, that you can analyze out there. So, you know, scenario is, one is like this, okay, which is a very, you know, square crossing, like the one I showed there. But often we have this shared path or cycleway or shared path running parallel with a major road. And that's really, it's a really good way to do it, especially if you're getting those major, you know, those major projects, and they're often, you know, they're often about traffic congestion or something like that. They're widening, they're duplicating a road, okay? They want to pump more vehicles through it. Well, this is our opportunity to ensure that we're providing dedicated facilities for pedestrians, for cyclists, okay? And we can leverage off that, make them do it. So we can create this running parallel within the road reserve, within the right-of-way. We have this dedicated facility. But if every side road we stop, we don't give priority for the cyclists and the pedestrians, we're making this really disjointed path for them, and it's just less attractive to ride. So if we provide the priority at these side roads, we get this continuous run for this road reserve as well. But we need to think about, okay, we need to provide some different sight lines here, same principles, but slightly different. That vehicle needs to be able to see that cyclist approaching there. They need to be able to see the conflict point. They need to be able to see a cyclist coming from the other direction. We need at turn points for that to happen. And we need the vehicle coming from the other direction to be able to see that. So what we end up is not a sight triangle, it's this sort of sight envelope that we need to be keeping clear and free of obstructions in these scenarios. We understand and we assume, I mean, it has to happen, that this vehicle has to slow to make their turn around here. Now, in some scenarios, you might adjust this from what we think about as a 20 km/h curb return speed, the speed the vehicle will be hoiking around that curve. If it's a really big radius sweeping curve, you're going to have to up that a bit, right? But if you think about a 20 km/h turn speed, that then helps us in some of our decision making. So what we want to do is we want to work out B, A, these are our critical distances that we're thinking about. The other scenario, we've got what we call A there, and then this one is a C scenario, which is creating that sight triangle. And there is a third scenario, which is where we have that path running parallel, but it's making that crossing of the road at some point. And we see that out there. So there's sort of your 3 scenarios to work through. You use the same formulas, you're just thinking about different specifics in that. So the way we do this, to calculate here the distance A being the bike setback, we think about our speed scenario. In fact, I've got this, the travel time scenario, land use scenario. So we pick one of those. Is it a lower speed environment, and we can take a low travel time speed? And then we move this to our choice on the speed of the cyclist. And I talked about that. 30 km/h. I mean, we're talking a cycleway. They're hammering through there, right? Down to 15 is there, you know, cyclists are really navigating around this area. And what we do then is we're looking here for A. We base it on what we've chosen as a cycle speed, what we've chosen as the road environment, and then you find your corresponding distance for A. The distance for B uses the same principles, and we're talking about the main road operating speed here. So this could be an 80 km/h road. They're hammering along. They've got to slow down. They make their turn. Well, how far back here do we need to make sure they can see cyclists? We use the same thing. We go 80, and then we go the travel time choice there, which we're back here. Travel time choice from table 1, and you pick your corresponding travel time, for example. And then C is similar. So you can see here a quick table on this. If we've taken a 20-km shared use path, as somebody did nicely earlier on, and we've decided on a 3-second travel time requirement, and there's a 50 km/h operating speed of vehicles. You can see there that we want to provide that 17 meter for A and 21 meter for C. Hafez, I'll answer questions before I promised people I could have a coffee. So I'll answer a couple of questions, give them a coffee break, and then I'm going to ask them a question when we get back and we get into it.
For sure. So I think like 2 questions, I think like more prominent here. One is about the color, the paint on the cycle lanes. Like, Queensland uses yellow. Somebody mentioned here, Western Australia has used green. What are your thoughts on the color?
So the convention is, and so most jurisdictions are using yellow for a shared path, so pedestrians and cyclists. Green if it's cyclists only, like a cycleway or the like, and then just pedestrians get a standard zebra crossing marking.
Excellent. So the other one is when we talk about blocking the sight distance, what if the object is a very narrow hole?
Yeah. So there are some specifics in both the Victorian document and others talking about what we consider actually a sightline impediment. Certainly 100 mils is bandied around as that, but you make a judgment call on that as a designer.
Awesome. Well, thank you, Ken.
Okay, let's take that short break. And yeah, so come back in 3 minutes. I'm going to keep going from here and ask you a question in 3 minutes.
Beautiful. Thank you, Ken. 3 minutes, 11.5. Beautiful. We have, on the spot.
Okay, I'm going to keep going, but we've come up with some calculations on these sight distances and the like, and I'm just going to jump in here and show you the TMR supplement to 6A, Paths for Walking and Cycling. Have a look at that with some of those slightly different, I talk about an 8 meter setback there, not quite the same exact scenarios, but that's your reference document if you're in Queensland to have a look at, taking into account the principles we talked about. But my question here is, what if you cannot get those sight triangles? We talked a little bit about this for pedestrian crossings. I'm now in the shared path or cycleway crossing scenario. Is it just all the same things, or is there anything else that anybody can think of? Let's see if anybody pops something into the chat there as we get back into it here after our little break. Any ideas, people? What can we do if we can't meet the sightline requirements on the approach to a shared path crossing? Cool. Okay. Now we're getting some good answers coming in, aren't we? What do we got there? Tom's saying, again, you might want to start questioning the crossing control. And we've got traffic calming. So make them stop and see. I assume we're talking there about, is it the bike? So we would be talking about changed priority there, or we might be even talking about making the vehicle stop and see, which is another option. Oh, good. Lots of great stuff coming in. Fez, I'll let you decide who gets prizes here because this is all good. I've popped a few in. I think some others people are popping in could be added as well. Speed management for the cars. That's where I like to start and say, okay, well, we haven't got the sight distance. Let's slow the vehicles down at this crossing point. I mean, we've decided it's got enough pedestrians and cyclists that we're going to make their path priority, or we want to encourage enough of that. Thus, we can certainly slow those cars down further on the approach. Then you can look at trying to calm cyclist speeds on the entry. Remember, they're the critical ones. And if they're coming in at high speeds to a conflict point, there is the possibility to slow them down through maybe a chicane or a horizontal deflection of the path, or even a vertical deflection of the path, a raised little bit for the cyclist before the conflict point. You may decide in some scenarios to pick a lower travel time. So that's one of the parameters you're choosing from. And then you might be into, as a couple of people pointed out, considering, is the raised priority crossing suitable, or do we need to go to something else? But certainly in my lots and lots of discussions with DTP, Victorian government, a lot of the major projects putting in these on these roads parallel, it was really good to hear that they have never stopped a priority crossing going in on a shared path since the release of that guidelines. Instead, they've worked through these scenarios with the design teams to manage vehicle speeds on the approach, to manage a little bit of cyclist speed on the approach, and being able to get them in satisfactorily at every point. So yeah, this one is slowing vehicles on the approach point now that one's actually a slightly unique one. It's a bit more about drainage than this specifically, but it shows you slowing vehicles on the approach is a possibility. This one, an interestingly weird, shared path down the middle of St. George's Road, for those who know the area, but, trying to enforce vehicles to actually come to a stop at this location, which, you want to try to put as many features in to ensure that. So you'd really want to slow vehicles with physical stuff. This happens to be that you've got to turn into it. So you're actually really going slow anyway. So it kind of configures reasonably. Okay. So let's talk about positioning of raised crossings around roundabouts. I talked a little bit about that. Now, really, you've got two options here. One option is to have your crossing right up at the hold line, as you can see in this one. So you can see there, right up at the hold line, you've got the crossing there, the raised crossing. The second option here is to sort of set it back maybe 4 or 5 to 8 meters. You can see it's sort of set back a bit from the hold line there. You've got that buffer. Now, the scenario I've laid on there is around vehicles, cars sort of entering into the crossing, into the roundabout. Now, in this scenario, we have vehicles that are waiting for pedestrians and they're clogging the circulating carriageway. Now, personally, I don't care. Right. And the reason I don't care about this is that this is obviously a high pedestrian priority area. Moving vehicles through there, at speed is not what the purpose of that area is. Okay. Yes, this scenario means that they will be able to, wait there and sort of, still circulate around. So it's going to be a bit more efficient for traffic flow. But actually, the reason I prefer number two is not to do with that. It's actually to do with the vehicles entering the roundabout. Okay. Now, if they are waiting for their opportunity to come in, under this scenario, they sit right over the pedestrian crossing. And it's not the most risky thing, but we do have to see then pedestrians walking around, going down, up, and certainly mobility challenged pedestrians are very much stuck there waiting and the like. So that's the reason I say that this is the preferred one, because we have that area where most vehicles can just prop out of the way. The next vehicle will prop back, and there's that clear pathway for pedestrians to cross. And so there's an example. And I think this one's also maybe covers off on a little bit of that. I mean, enough space there, got the curb out stand essentially, which, but still got the cycle facility there. So it's not constrained it down and narrowed it down so much. Just to cover off that little one. But you can see there's enough space for a driver to come up to this. If a pedestrian's crossing, wait. They can prop over and wait out of the way of pedestrians crossing. And I think the 5 meters, thinking about the length of a car. There's the sort of alternate right up on that down South Melbourne area. And certainly that can work. You just got to be conscious of that. Some vehicles will prop over the pedestrian crossing. Okay, the next thing I want to just briefly mention is the angle of approach on any raised feature on the network. So we really want to try and provide that perpendicular right angle. So any larger vehicle that's navigating over this doesn't hit it with one wheel first, go up and then get that rocking destabilization. That's our objective, and that's why we try to keep everything as square as we possibly can. So let's have a look at this one here. And this is a proposal for a raised signalized crossing, which I love. Love the fact that somebody's going, even though it's signalized, we're still going to think about severity of crashes. Fantastic. All right. You can see it's on this bend though, and you can see as designed, larger vehicles may be hitting that with one wheel first. Motorcyclists will also be on a little bit of a lean, so not the sort of ideal. Any ideas from our wonderful participants on what slight design changes could we make to this to make it a bit, more appropriate for heavy vehicles and motorcyclists particularly?
And this is the 4th prize.
Oh, good. Yeah. We're giving out lots of prizes today. And we'll see if anybody's got any ideas. Okay. I think Emily's onto it there. Oh, they're all good. First, can we give prizes to all 4 of those?
Yes, we can. So, but what if other people say that as well? Because everybody's saying it.
I'm going to leave you to make those hard
the
choices.
First 2, we give it to Emily and Callum.
Okay, good. I like it. So the ideas in there are good. Either we're going to try and slow vehicles back here where it's where it is perpendicular to travel, or we alter things. So one of the proposals was a flared crossing, which is fine. I mean, it doesn't need to be, the raised part doesn't need to run exactly parallel with the crossing lines. So that's a possibility. Or something setting it for bringing it back, or particular raised points there. The principle, again, think about the principle. The principle is to lower speeds at the conflict point. Make sure vehicles are going at low speed where they're about to hit a pedestrian. Try and do it on as much of a parallel, perpendicular as you can. Okay, positioning at roundabouts, again, different guidance. The Victorian guidance on bicycle and pedestrian treatments at roundabouts is a reasonable document. It's getting a little long in the tooth now, but still some good stuff in there. TMR's got some good stuff, but you have to jump between 4 documents to get it all. But those 4 I've put in the notes so you can jump in and have a look at that yourself. Okay, another example here. So this one you see is a cycleway, although is it marked as a shared path? It is marked as a shared path. So technically that should be yellow. you can see there the setback is going to be good for the vehicles exiting, the vehicles entering. There you go, I drive a little car in there. You can see they're propped out of the way. If they're doing that right turn in, they can pause and not be impacted by vehicles coming this way. So it's a nice little buffer area. All right, ramp grades. How are we going? I'm going to have to move a bit quicker here. Ramp grades. Okay, there's Fez and I out there measuring some ramp grades down in Caulfield. That was good. But here's the basic principles. The harsher the ramp, the more people slow down for it. Because they sit, so, harsh ramp, slower speed. Gentle ramp, faster speed. Pretty obvious, pretty, but as I said before, important thing to remember is they're making their decision back here. They don't hit it and then make a decision on the speed to go through, right? They make a call based on what they can see, what they're perceiving, what the advisory speed says, and importantly, their history of driving that point. Because most drivers have driven this road before. The bulk of drivers, right? If we've signed something very shallow, very easily shallow down at a 25, it may be the first time they do it, they'll go down to a 25. Certainly not the next time. Okay, so what we talk about there is ramp grades. So, and we talk about it in a 1 in something. So here we've got 100 mil high ramp, 100 mil high platform, a 1.2 meter length. Quick prize for the person who can tell me what's the ramp grade there. Pop that into the chat. A 3.6 meter length of platform. This is a very standard raised crossing. Who was in 1 to 12 first there? Andrew.
Andrew got it.
Gold Coast Legends. Okay. There you go. So that's going up 100 and out 1200, right? So that's what we talk about with ramp grade there. Tough field, yeah. But I want you to remember ramp grade is relative to the longitudinal grade of the road. So you've got to keep that in mind. Okay, so here's a wonderful graph, CDM research graph, and it's certainly used by a lot of the decision making. We've got different ramp grades here, and we've got here vertical acceleration. So that's, the driver, how much up and down are they going to get to that, right? No speed response for this area. Now, uncomfortable is an understatement here. This is like almost like, it's really bad. Possible vehicle damage, you can see even sits under that. This is where we want to be. I mean, this is where it will play out. This is what they will settle themselves very quickly at in terms of the speed they travel through these crossings. So what you do is you work out what are you looking for, and you can get a ramp grade accordingly. So 1 in 12, we can see is going to take that trajectory, isn't it? And we can say there, okay, we're going to get somewhere in the 24, 23, 24-ish range, 25-ish range. Okay, so it gives you that nice ability to understand what speed are we going to get through based on the ramp grade. If we took 1 in 16, we'd be thinking, okay, it'll be a little bit above 30. Now, lots of different things in different guides and points about it. So I've just listed all this, the Austrode stuff, the Australian standard stuff, talking about heights, lengths, and the like. So that's in your notes for reference if you want to dig into these in more detail. I'll put the TMR stuff, the Waka Kotahi NZTA stuff in there as well for you. So I've just dot pointed all of these references. They generally, there's a general consistency, but a few anomalies within there that sort of sometimes, it's quite blow my mind. 150 mil high one that's high. And I'd be really interested to see actually some of those out there in different road environments. But let me explain why sort of that is. You got a 100 mil, which is a pretty stock standard height, you could lengthen your, the ramps as one thing. You could raise it, as we talked about, and you could vary the length raising it. So these are going to change all of the ramp grades. You could have lower ones with different ramp grades. But what we're thinking about, okay, is a car going to hit its front end as it comes in? Is it going to bottom out as it goes over the top? Is its back, its tail overhang going to scrape? Is it going to scrape as it comes down? So they're all sort of factors of consideration that we take into account. Usually cars perform pretty okay in most of them. What we often really need to think about are our larger vehicles and their clearance. Now, we know vehicle regulation, ADRs, and they're based on us understanding some specifics around a vehicle. Buses become a very important one and something that people get very concerned about. And I often see people deciding, no, we can't do a raised crossing because it's on a bus route. No, that's not true. You might need to design it slightly differently, but you certainly can do raised crossings on bus routes in every jurisdiction. Let me talk you through the buses though. And this actually links with the heavy vehicle, that diagram I had before that I didn't spend any time on. What we're thinking about are the distance between axles and the maximum percentage of X that can be taken. And then you see it's a similar one at the back here. And often buses will sit up. Whoa, what did I do there? Often buses will sit up, taper up on the back as they do. So if you took a standard bus lengths, 12.5, they usually have that 190 clearance. These are some New South Wales specific diagrams, but you see angle approaches and front clearances are important. And you've got wheelbase is another important one. We can think about long rigids. We can think about articulated buses and their ability to tweak. But essentially, if we take some of the worst bus scenarios being a coach, so your public buses are usually higher, but your coaches, that 150 mil, it's actually going to strike it coming into it. The 100 mil, it's just on that point. The bus will be able to get over that. It will bottom out over the 150. It'll be okay under the 100, and it'll bottom out again over a 150. So there's more information from the National Heavy Vehicle Regulator on more of the specifics of buses. You can get a huge amount of information on that. But here's a picture of a coach back at that crossing I was pointing out before. You can see a coach there on a 100 mil high, 1 in 15 ramp grade. It navigates it fine, right? Yes, it slows itself down so it doesn't bounce over it and get that, because it's pretty close to touching it, but it gets through it fine. And that's an absolutely acceptable ramp grade and height. And it's a very standard crossing, raised crossing. That's acceptable on routes that are going to get buses, but not your every 10-minute commuter bus route. It's going to be a significant sort of impact on that if it's that many of them. You can see the commuter buses, though, they tend to have more clearance and they're able to get a little bit more out of that. The 75 mil high and the 1 in 20 ramp grade. So it's flattened it a little bit. You start to lose a little bit off the speed calming of the vehicles, but you're accommodating the buses quite nicely. This is a nice setup. There is an option also in some circumstances to elongate it so the bus doesn't sort of sit over it. It can do essentially a 2-stage movement, which can help you in some circumstances to be able to get higher ramps if you need it. So this one's an interesting one, which is a 75 mil high, 1 in 27 ramp grade. Now, the buses are going to have no problems here. They're going to cruise through that. But vehicles are going to go fast. Like they're going to go through 55-ish. You're really not getting any advantage out of that from a raised crossing, apart from maybe it contrasts the surrounding environment a bit more. It looks like something, but so you're finding that right balance. To me, that is far too shallow. This one is really great for your bus routes. If you find yourself in that scenario, though, where absolutely not, we can't do this, there is still the ability to slow vehicles down on the approach to the conflict points with speed cushions, so buses can straddle these. It's going to have no impact on the buses in terms of their vertical deflection in terms of up and down. They will probably slow down a bit as well, which is good, but certainly vehicles will likely slow down on the approach. Make sure you do them on both sides of the roads, unless you've got a big longitudinal separator, because if you just do it on one side, vehicles drive around them. But that's a reasonable setup as well. It's a much lower cost way of getting that principle of controlling speeds at the pedestrian crossing point. And there's a couple more examples, one there from Prue, she may have shown, and you can see this one here, which they've done a little bit of a spike down separator. I'd probably like to see that extended a bit, just so you really still minimize the possibility for vehicles to, when it's low volume and the like, just sort of shoot around that and chicane around it. And you can do permanent ones, so actually cutty and asphalted ones, or you can see the spike down ones are a possibility as well. In terms of speed cushion design, they're 75 mil. You can see there the wheelbase straddling that you want for ensuring that the coaches and the larger vehicles and the buses just straddle it between their wheels. Pop that in there just to show another one, which is that you can even use these sort of approaches on some of your more major arterials with signalized crossings, because really at a safe system principle level, we've got a vulnerable road user crossing the road. Yes, a red light is going to stop a lot of people hitting them, but some will still, for one reason or another, miss that. And if we can slow vehicles, we further enhance the chance that they stop. And second of all, if they do collide with the pedestrian, we're in territories where it will be survivable and likely that they will recover to lead a normal, healthy life.
Ken?
Yeah.
A comment question in the chat room about SUVs and the change in the fleet and the impact on the design.
Yeah, I mean, it's a constant battle trying to do this and keep up with the changing vehicles. No, not just from a raised crossing perspective, across the entire board. I mean, we saw the changes in barrier configuration requirements with the introduction of MASH to try to cater for the higher vehicles. Now you start to see much heavier vehicles coming in with electric vehicles, and now we're thinking, oh God, we need to change this again for barrier systems. We see, the same for raised crossing and different calming facilities. Okay, we came up with a lot of that for normal standard, 1980s, 70s, 90s vehicles, and now we're into these higher vehicles and suspension. And you're even seeing technology starting to play where vehicles are. I'm really scratching my head on this one. There's a vehicle, I can't remember which vehicle manufacturer it is, but they have, in fact, configured their suspension to actually be able to navigate over our raised platforms without having to vary their speed. So so that they'll set, they're putting smarts into the vehicle. So, part of me goes, okay, it's not the worst thing, because at least we know that vehicle is going to have auto emergency braking, and they're going to be reading the road environment and seeing things. So it's a far safer vehicle from all those perspectives. It's doing not what we've designed. Yeah, so it's a continuously ever evolving field, and we need to keep working on it and keep adjusting our infrastructure design and choices and decision making and standards around it. Picture in here from Waka Kotahi associated with the fact that you don't need your exit ramp grades to be the same as your entry ramp grades, especially, a critical aspect to that usually is that you have a separator between those two, because you don't want a flatter ramp grade and a harsher one. If a vehicle is slightly out of their lane, then they really would get a destabilizing effect. So, you can do this, and that can again provide you with just a much gentler exit for some of those vehicles. All right, I gave you a very simple diagram of a longitudinal grade entering into a raised crossing, and it becomes pretty specific and nuanced. The reasons for this is that, okay, this is a big downhill here, a big downhill, and then it comes into this. And so the question becomes, okay, we want to raise that crossing. That's fine. We could certainly configure it. So the shared path here, the crossing, isn't on such an angle that somebody in a wheelchair or the like would be sliding down it and sort of falling off it, right? So we could configure it like that, but it comes with some challenges if you do that. So there you go. You can see that we have configured this one to be nice for a person crossing this. However, you can see immediately that our bus is going to have trouble, isn't it? It's going to have trouble as it enters that. It's going to have trouble, and it's going to get stuck on it. It's just far too high in order to keep that level. So we can sort of play with our configuration there and lengthening it to try to still get that visual speed reduction for the approaching vehicle, but to be able to cater for these larger vehicles. Now, in some of these, you get some pretty long pavement raises and the like, but certainly there is the possibility to do it if you need to. So this one could just possibly work, but you'd really need to lengthen out the taper there. There is the possibility, though, just to put a speed cushion there on the approach, which would do a lot of the work we're trying to do. It also probably help you with your drainage significantly as well. So there is the possibility. I popped this on LinkedIn a while back. I was just quite amazed at some of the ones I was seeing in Dunedin down in New Zealand on race crossings on these grades. And again, accessibility and understanding the nuances of that isn't my strong suit. So I was sort of asking people their opinion a little bit, and a lot of those experts in that field sort of saying, well, you're on such a steep grade of a road anyway. I mean, you're like, people are slowing those vehicles down is giving a significant advantage in this case, and that's sort of something that you kind of live with. We prefer that to be raised than not raised. But interested in anybody's specific thoughts on that. Of course, to flatten that out, I mean, it's going to be huge. The emergency vehicle one that we talked about a little bit, I just again put that link to that article, and I think it's a beauty. And that, emergency responders told us race crosswalks had no effect on their response times, and they actually prevented incidents the responders would have had to respond to. What a beautiful statement. I think that's a really good one from the Federal Highways. We do have a fact sheet, which I can bring up shortly on the Safe System Solutions website around raised crossings that also points at some of the emergency vehicles, but more in a sort of principles perspective, which is essentially to say, emergency vehicles slow at different points on the road network? Absolutely. Certainly going through a signalized intersection, a roundabout, and these features, they slow. They have to, and they do, and they're happy to do that. And really, race crossings aren't going to have major impacts on their travel time. So there's been a discussion around the 3D crossings and the like. I mean, you remember I said, Hafez, that vehicle drivers, most of them have driven that area before. And so what we see with these, like, it's funny, like 20 years ago, we trialed this in Rutherglen in Victoria. And of course, it emerges itself with social media now and then, like it's going to be the new thing that's going to save us from super cheap way of doing it. Well, the reality is it'll work for the first little bit of time, and then everybody knows it's not, and it's not actually raised, and we'll have our speeds back to pretty much exactly what they were. So there's lots of new shiny ideas out there. You really want to analyze them, evaluate them, get proper evaluation as well, because don't do like speed data before and then speed data one day after it opens, because of course it's going to have come down. You need to, maybe you do it one day after, but then you need to do it a month after, and then 6 months after. Okay. I'm going to try and leave a little bit of time for questions at the end. I don't know. Hafez, you might be able to dig out an example of a 3D design. There's just, perceptual. Well, Hafez will show you. Okay, lighting. Lighting's complex with raised crossings or crossings of any form. I point you to the Australian Standard 1158 on lighting of roads and public spaces, and part 4 is lighting of pedestrian crossings. So essentially what we're trying to do is illuminate the pedestrian in multiple ways. And if you think about it from planes, right, we want to actually illuminate across all of these planes at ground level, but also sitting up at a height, and the height being 1.5. So lighting is about ensuring a driver can see that there's a pedestrian crossing, but it's actually also in there to illuminate the faces, essentially, of people crossing the road. And that's more of a personal safety lighting sort of consideration. So what you have to do is you do a lux analysis. There's software you can do it with, and you're really trying to ensure that you get that lighting across these planes, and it comes from both sides. So you'll see back there, which is a decent diagram, that's kind of your ideal. Now, lighting used to be one of the huge challenges and costs associated with raised crossings, and it's often around power supply. I'm really excited by some of the work Geelong City Council has been doing, and now others are following, associated with solar-powered lighting at crossings, and it's a bit of a game changer in one sense, that we can really do that. Piggybacking on existing lighting is often good. It can sometimes factor in exactly where you'll position a crossing, although desire line should be a real big driver of where you're positioning a crossing. We've got this real detailed design course for raised crossings with my colleague Jonathan Gordon, who's your real hardcore microstation civil designer. He delves into a bit of this and positioning and civil infrastructure and services and drainage and in those really sort of hard detail. I'm just making sure you're aware of the principles around lighting and drainage. And shared paths, you want to think about, again, our A's and C's, and starting ensuring that we have that lighting back there. But the C is not as important because the lights are on for that vehicle. So the cyclist approaching is aware that there's a car coming. Drainage, another one that makes designers shudder around raised crossings, thinking of how we manage this water that is going to arrive. And we've got essentially 5 choices on how to manage water with raised crossings. I've got 6 pictures there. Keeping the curb and channel just running through like this one, I put a red cross next to. I mean, that certainly doesn't meet Bridget's, what is it? Smooth, step-free, obvious. What's the other S for? Smooth, obvious, step-free, step-free. Is that right? Anyway, I have to go back to look. Safe, of course. Give Natalie a prize. Safe, yeah. It goes without saying for me, but no, good. Safe, obvious, and step-free, smooth. Not meeting that, so let's not do that. Okay, low ramp height. So that may be a determination that you can actually flow your water over it with a shallow ramp height and just accept that that's a, just almost like a natural deviation in the road that you don't take it. Positioning at the high point is going to be a beauty. Now, if you just happen to be lucky enough that the high point of the road is a desire line, your water's just going to naturally flow off it. You don't need to worry about that at all. Now, sometimes if you were in actual greenfield subdivision style design, that may be something you consider. I don't know if anybody who's actually really made that a initial starting point, but I'd love to see some of that going on. Okay, ramping down and ramping up here is one you can pretty much keep your curb and channel and your path of water there, and then you ramp up to a height you want. The curb outstand there is such an important part of this. Otherwise, vehicles are shooting around it with the low side. They're dropping a wheel into these areas, and we're losing some of the speed benefit. Box drains and different configurations of box drains there. I'll show you a couple of examples of that. It's essentially where we run the water through that box drain. And then, of course, pit and pipe, and actually dropping your water in to the system there. You may need to increase capacity of that as they're doing in this location. Okay, so here's some examples, and the box drain style thing. You want to start to be thinking about maintenance of it, leaf litter, and the like. That certainly builds up in there. Some of these wider ones pretty good, and you can see that nice continuous step-free arrangement with the TGSIs and the like there, and one from New South Wales down the bottom there, another one in here from Victoria, but this one even there for that pre-opening audits, a very, very recently built, has already clogged with the debris and the leaf litter and the like. So it's something you want to be cautious and conscious of. Certainly maybe making this a bit wider, accounting for some of that would have helped, and giving it its maintenance clean outs regularly. Interesting one here as well. They've been able to use a bit of water sensitive urban design style thinking, having water coming in and areas where it can flood a little bit, and they can put planting and the like in those areas, but use it as that bit of a basin. And here's another one which is going into the pipe system on the approach there. That's a bit more of that water sensitive urban design cut in. So yeah, the key things around this is to ensure that we've got a pretty long down and up here, because mobility scooters and others, if it's a very harsh down and up, will be really struggling to navigate around that. So if you're in fairly flat areas, it tends to work quite well. And when you start to get non-flat areas, it becomes pretty challenging. Another reasonable example here, you can see it works quite well. This one, I think we're going to have trouble here. It just drops too far down and goes back up too quickly, in that a mobility scooter is going to really have a lot of trouble with navigating that. So that may not, in this scenario, have been the best decision. And again,
also, sorry, Ken, for interrupting, but also we've heard about the elderly and, people with, disability, that has been a problem.
absolutely. And I think I got a picture here, yeah, of this elderly lady sort of navigating this one, which she manages to do. She takes quite a while to do it. Now, it gets me in this real conundrum, and I don't have the best answers for it. Like, if we can get another 3 raised pedestrian crossings in at the cost of making this one with pit and pipe and the like, I want 3 more raised pedestrian crossings, right? But I'm absolutely not saying that this is not something we really need to consider strongly. And I think there's elegant designs that you can do that meet both, and we should be looking every time we can to try to adjust that. Just in the last few minutes here, Fez, signs and lines. The 1742-10 sets us out what we should be doing in signs and lines associated with a raised crossing. We want to give advanced warning that there's a crossing coming up. We want to put the no parking, no standing, no stopping signs. We want the raised signs, and we want the legs to give it legal priority. We want the line marking there to give it legal priority as well. You want to think, don't have your signs too low that people are going to hit their head on them. 2 meter high is the usual associated with that. And if you've got anywhere where vehicles might turn onto a crossing and not, quite see it from that perspective, you want to provide those advanced warning signs. Interesting one here, which I'm okay with. Some people get very angry at this. My colleague Tuan gets angry at this because 2 regulatory signs on the one post is a no-no under very strict standards things. I think it's such a low-speed environment. It's doing the job that I'm not as concerned about that. Now we have quite the sign set up, don't we, here? And I'm lobbying or trying to push for some jurisdictions to trial something that gets us a few less signs, because I think the sign clutter on the approach to raised crossings is a bit extreme. In some cases, it's probably far more than it needs to be. Have a look at that. If you're in New Zealand, you might use the triangle on the approach as well, and you use a slightly different line marking configuration as opposed to the Australian piano key markings that we use under 1742. And again, the New Zealanders use the different, they don't use the walking legs, they use this thing, and a slightly different warning sign if you're in New Zealand. Might jump through that. Yeah, so until the Australian standard comes out with this sign, which it's either out or it's about to come out, you can have a look at the Queensland one, and other jurisdictions are just using that as the standard one anyway. And I've popped some more references in there to make your life easy. Tactile ground surface indicators, RRPMs, flashing lights for some jurisdictions, which I won't go into the details of. You just lay them out as per the standard. Okay, just note on these ones, the ability for vision impaired people to contrast red on white is not great. And so people trialing that setup, as you can see there, it looks pretty obvious to me with good vision and ability to see that. It's not recommended as a color treatment because of that challenge for vision impaired people to contrast and see that. Yeah, here you can start to see some of the sign. There's a lot of signs going on there. Do we need all of that? I'll let you ponder that. Technically, the arrangement is correct. Stop sign up here for stop for the road, give way for this, that for that, the raised bit for that. Some advice on the speed you do it. Pavement. I did tell you that I'd whip through a lot of design features just to give you enough to go, oh yeah, I see what we're doing. So there's different ways to do this. You can either use asphalt, concrete setups, boxing out there in terms of cutting in. You want to do that so you're not creating an area that'll chip away as such. You can see a bit of sort of a box out cut there to give that point where it holds. And then the pavement specifics, pavement design on the approach and braking area. I don't have enough pavement knowledge. I get pavement people to help me with this, but those are areas you need to think about. Is the braking zone on the approach to the crossing, ensuring your pavement strength is there, the boxing, and then your raised bit. The concrete is good at getting that sharp point. Some of the construction people are really good at that with asphalt as well. The concrete is a bit more expensive. It takes a bit longer to actually build, but becomes pretty nice. Coloring your concrete a bit is better because white lines on white concrete don't stand out too much, but a bit of a darker colored concrete then gives that nice contrast. So something to think about. Okay, Hafez, I'll take any final questions. I did rip through there pretty quick there. I do need to show people in the learning management system how to finish the course.
Two questions.
Yeah.
I think one of them is procedural. So based on your familiarity with the system, what is a process, approval process for raised crossings in Victoria, say?
So in Victoria, it's considered a major traffic control item. So a council would need to get the Department of Transport and Planning's essentially approval on it. Technically, I think it's the Department of Transport and Planning needs to approve the erection of a feet sign because that's the major traffic control item. And there's a little clause in anything raised as well. But so yes, you do need to be in touch with your state jurisdiction in that perspective. I'm not exactly sure what the requirements are in other jurisdictions.
Thank you. And Ken, based on your experience, we want to have cost-effective raised crossings to do as many of them as possible. What are the best way to achieve cost efficiency?
So the big costs associated with raised crossings usually are the drainage and the lighting. And so I'd look for the opportunity to do that sort of ramp down, ramp up at shallow grades in your flatter areas and use solar powered lighting. And you can start getting them in fairly low cost. If cost is being a significant hurdle, I think we get some pretty great benefit out of the speed cushions on the approach at very low cost. Not as good though, in the sense of you do get some safety advantage for a pedestrian being slightly elevated as they cross. Drivers sort of see them a bit. You don't need to do these multiple slowing points. It's the one slowing point. You need to kind of do those on both sides otherwise. But for the cost and what it is, it's pretty exceptional, really.
Totally. So Ken, these are the main questions. But before we go to the LMS, thank you very much for taking us through so much material. And also, I want to thank the audience here for bearing with us, coming along, asking all the question, participation. It has been an amazing, I'm talking on behalf of the team, it has been amazing to have you. So we go to the LMS and that will be it. Thank you, Ken.
Good. Hafez, you can see the LMS? Yeah, good. So hopefully you're very familiar with this now. You've got some resources in here, and I think I've put a road design and engineering resources, a whole folder in there of stuff, some of those that I've mentioned, so you can go in there and have a look. The Raised Safety Platforms brochure that I talked about, you feel free to share that with stakeholders if they're grumbling about different aspects, because we try to cover off a lot of those myths around, emergency vehicles, noise, impact on travel times. It's, we try and cover off those and explain that they're not the issues that people perceive, or that they can calm down. Down here on the how, which is what we've just done. Now, we've got a quiz for you, all right? You have to do a 10-question quiz just to show you are listening through these modules. It's fairly simple. And once you've done that and you get more than 8 out of 10, you're able to go down here, fill out a course feedback, and then your certificate will release. But it won't release until you've done the quiz, got more than 8 out of 10. You get 3 attempts at it. And really, I don't think you're going to find it too hard. And complete the feedback, and your certificate releases. Where's my water?
Oh, poor you, Ken.
I get too excited about race crossings. Okay. And of course, you've got in the welcome stuff and the pre-course material, the agenda and the like. In there, you've got our contact details under the who, the where, the why, and the how, and the certificates. And of course, reach out to any of us at any point as you're ticking along your journey, installing as many raised crossings as we possibly can, because we want to help you make sure that happens. If we can provide you resources or advice or connect you with people, we'll absolutely do it. Thank you, Hafez. You're a wonderful moderator, as always. Somebody early on said, oh dear, the energy with Hafez and Ken in the room could be quite unstoppable. We do get excited about this topic. A wonderful group, great information there. I do flag again that if you are into the details of the design, I've given you some of that. But if you want to see, getting in MicroStation or CAD and making those choices and looking at exactly those service relocations, drainage, how much drainage do we need, lighting and the like, there is this detailed design of raised crossings course that we're about to launch. I think some of you have already booked into that, which is great, or you could share that with your detailed design team if they're pushing back on you getting some raised crossings in. Well, maybe they just need to get a little bit more knowledge on how to do it rather than how to say no to it. Thank you, Hafez. Thanks, everyone.
Absolutely. Thank you, everyone. You have a lovely day. Thanks, man.
Bye.
Bye.